Hello, and welcome to Lesson 9.2 on direct, inverse, and joint variation. So this is the lesson I taught in class so that if you were absent or if you just wanted to see it again, here it is, okay? And I'll try to hit everything that I did, that I presented in class. I kind of just freeballed this one, kind of just free form, just made it up on the spot, which is what I'm going to do now too. I don't have something written out in front of me. I'm just going to talk. Yeah, and here we go. So in this lesson, we're covering the main idea is looking at how variables interact with each other, the relationship between variables. And that's what we're going to mean by that word variation. Okay, how do variables vary with respect to each other, right? For instance, if I increase the value of one variable, what happens to the other? Is there a relationship between them? Does one go up and the other go down, or do they both go up, or what? Or do they stay the same? Ooh, who knows? Well, if they stayed the same, they probably wouldn't be variables, but that's okay. Unless, of course, we held them constant, which we could do. Okay, so let's start with direct variation, okay? Direct variation. All right, and I'm not going to worry too much about my spelling here. So direct variation is the idea that when I have two variables, as let's say the first variable x, as x increases, then y increases. And vice versa, if x decreases, y decreases. Okay? So this is the idea that if x goes up, then y goes up. And if x goes down, then y goes down. They have a direct relationship with each other. Direct variation is covered in Algebra 1, but, we're just going to cover it again here because it's pretty simple, pretty fast, and we're just going to throw it in here because it goes with this stuff. So I am going to create a column here to the right. I'm going to say this is my equation, okay? So the equation for direct variation is y equals k times x, where k, and I'll put this in yellow, k is called the constant of variation. Now, remind yourself, what does constant mean? Constant means same. It means not changing. It means not varying, yeah? K is what is going to help us relate these two variables. K is what creates this relationship, yeah? It's a constant value that does not change. Keep this in mind because this is very important when analyzing relationships between different variables. Okay. And by the way, maybe an example of direct variation would be, suppose I've got, I don't know, a cylinder. Yeah, suppose I've got a cylinder and I fill it up with water. Here's some water in my cylinder. So the water has some volume, V, right? And however much water's in there, it's got to be some certain height. So it has some height, right? Now, suppose I increase the volume of the water, so I add more water into the container. Ask yourself what's going to happen to the height. Well, the height is going to increase. So this would be a direct relationship. This would be sort of direct variation. As the volume of the water increases, the height of the water increases. And vice versa, if the height is increasing, then the volume logically would be increasing. Assuming that we're in the same container and that the radius of this cylinder isn't changing, okay? Making that assumption. Okay, next one. Next is inverse variation. Inverse variation. And this is sort of the opposite idea. It is just as one variable increases, as x increases, then y does not follow the similar path. It follows the opposite behavior. So I'd say y decreases. Okay, so if you want to say x goes up, y goes down, And if x goes down, y goes up. That is inverse variation. They are inversely related. And the equation for inverse variation is y equals k times 1 over x. And 1 over x is our parent function for rationals, right? That's kind of why we're introducing variation here and now in this unit. Because in some ways it's its own topic, but because we're talking about rational functions, k times 1 over x is kind of fits nicely in here. Yeah. Now, an inverse relationship might. I'm trying to think of something off the top of my head, but I don't really want to waste video time. Suppose. Let's see. If I have height equals v. Okay. So watch this, okay? Here, I'm going to create another cylinder, a tank, if you will, okay? Now, this tank has some water in it. Here's some nice, lovely water in the tank, okay? Now, here's what I'm going to do. I'm going to keep volume constant. I'm going to say volume constant. You don't have to write this down. This is just for visualization, okay? I'm going to keep the volume constant, but I'm going to increase the radius of this cylinder. So it's going to be the same amount of water, but I'm going to make it into a much wider tank. All right, like so. Then naturally, because it has to fill up, from the bottom, the water is going to be at a lower height. Because we're assuming that the volume of the water is the same. So if I do this, here's what happened. The radius of this cylinder increased. But what happened to the height of the water? It decreased. And so this is an inverse relationship, right? As I increase the area, or as I increase the radius of this cylinder, the height of the volume in it, of water in it, is going to decrease, okay? And that'll be my inverse variation example. All right. The last one, what the, get out of here. All right. The last one is joint variation. And all joint variation is, don't think about this too hard. It's just direct variation, but with more than two variables, okay? So I'm going to say as x or y increase, then a third variable, z, increases. Okay? So I'll say as x goes up or y goes up, z goes up. And similarly for decreasing, okay? And the equation for this is y equals k times xy. Oh, I'm sorry, not y equals, z equals. Yeah. Okay. And that's joint variation. So joint variation is just when more than one variable can impact the value of another. Now, a wonderful student question that has come up is, well, Mr. Spake, what if one goes up and the other goes down, right? So, like, let's say x increases and y decreases. And this is a fantastic question, by the way. Well, you might just have to ask yourself, how much is it increasing or decreasing by, right? For instance, I don't know, if I have, let's say x is 2 and y is 3, right? That's x and y. And let's say that I half 2, so 2 becomes 1, and I just double y, so y becomes 6. So, x is halved, y is doubled, right? Then 2 times 3 is 6, but 1 times 6 is 6. And so nothing changed, right? Because the value that you've increased by, right, you've halved one of them, but you've doubled the other, so it stays the same. However, let's say I tripled y. If I say x is half and y is tripled, then it'd be 1 times 9, and that's more. So yeah, x went down, but y went up more than x went down. So that's kind of what's really guiding this, or has more impact on, what's happening here. So therefore, your amount ends up going up more too. I hope that answers that question about if one goes up and one goes down. Okay. You just kind of have to think about which one has more of an impact and is going to lead to doing that. Okay. So here's a quick example. Maybe I'll switch to blue here. Suppose x varies directly, or I don't want to say x, I want to say y. I'm sorry. Suppose y varies directly with x, and when x equals 10, y equals 4. Okay? And I'll say write the equation modeling this relationship. Okay? So if I say write the equation modeling this relationship, I'll say, well, since y varies directly with x, I'm going to say y equals k times x. And then since y is 4, I'll plug in 4 for y, and I'll plug in 10 for x, and then I'll just solve for k by dividing by 10 on both sides. So therefore, k is 4 divided by 10, which I know is 2/5. Then the equation is y equals 2/5 times x. Done. Okay? This is just a quick example to show you how you solve these. Just read the verbal description to create the equation. And to create the equations, you just look at what's over here in the red, right there. So you just read that, create your equation, and then you just plug in the information you have to figure out the proportional constant k, or variational constant, and then you rewrite the equation with k substituted. That's pretty much it. Okay. So look, I can do another example. Okay. Suppose y varies jointly with, I'm going to use z. Okay, suppose z varies jointly with x and, oh my God, let's say x and y, and varies inversely with the square of r. I don't know. I just came up with a letter. So if I were to write this equation, well, the joint part, right? So z equals k times xy. That's the joint piece, right? And z equals k times 1 over r. But it says the square of r, which means it's r squared. This piece is the inverse. Okay? Now we're going to combine that. This is called a combined variation, because two things are happening, right? There's a joint relationship and there's an inverse relationship. So really, z equals k times xy over r squared. And this describes both a joint relationship and inverse. Okay, and this is called combined variation because I have more than one type of variation happening. It is both joint and inverse. Okay. Yeah. And maybe I say find z, or write the equation again, right? Write the equation if when x equals 10, y equals 5. No, I don't like that. I want to say 4. I like that better. I'm so sorry. I'm making this up on the spot, like I said. Let's say when x equals 10, y equals 4, and r equals 6, then z equals... hold on. Mr. Spake's going to do just a little bit of mental math here. Hold on. Would you just give me just a second to just process things? I'm going to say z equals 9. I don't care. I hope that's I don't know, whatever. Okay, let's just plug these things in for fun, okay? Let's say z is 9. So this equals k times xy. So that's 10 times 4 over 6 squared. So that's 9 equals, 9 equals, that's 40 over 36. It's 40 over 36. 40 over 6. I'm doing mental math here. Divide both of those by 4, and you get 10 over 9. Okay, so multiply 9 to the other side, and then divide by 10. So k equals 9 times 9 over 10. That's 81 over 10. Okay? Therefore, z equals 81 tenths times xy over r squared. Done. K was 81 divided by 10. I thought I might squeeze out a nice pretty number there, but I didn't, and that's okay because they're not always going to be pretty, and it's literally fine. Okay? All right. I mean, that's pretty much it, but I did say one more thing in class to help you guys write verbal descriptions from equations. So let me go ahead and do that, okay? So something you're familiar with, or should be familiar with, is volume equals pi r squared. This is the volume of a circle, yes? Or what am I doing? Mr. Spake, hello? Hello? Volume, you mean area? Yeah, that's what I meant. I'm sorry. The area of a circle is pi r squared, yeah? So how could I describe the relationship here between a and r squared, right? How could I describe those relationships? Well, if you think about this logically, right? If r squared, or even if it's just r, right? If r goes up, if you increase the radius of the circle, then the area is going to increase, right? And if you decrease the if you decrease the radius of the circle, then the area is going to decrease, yeah? So this is obviously a direct relationship, and we can see that from the equation because this looks like y equals k times x squared, yeah? So it's direct variation. So I will write this as a verbal description. So I'll write this as a variation. A varies directly with not r squared, but the square of r. The square of r. Now look, if you write r squared, I understand what you mean, but a lot of textbooks and just videos and, I don't know, college professors and just people, they're just going to say the square of r, so I'm going to say the square of r. I'm going to conform and say that, okay? Because it's fine. It's the same thing. It's the same thing as saying r squared. And if you want to be more particular and say that the area varies directly with the square of the radius, then you'd be fine to do that too, okay? All right. Now, let's give this some, let's make this volume now. If you, by the way, this was a circle, if you didn't know. If I give a circle height, then it becomes a cylinder. Yeah? So this is now a cylinder with a radius r and a height h. And the volume of a cylinder is, sorry, not 2. It's just pi r squared h. Okay, so now I've got 2 variables. Now, if you think about the radius, right? If you increase the radius, then the volume increases, right? That's like just making a bigger cylinder. So it's going to hold more, right? So the volume of that cylinder is more. Similarly, you could increase the height of this cylinder, and so its volume will be greater as well. So I could also say if h goes up, then volume goes up. So this is a joint relationship because both r and h affect volume the same way. So they work together to affect the volume. Okay, so I'll say that the volume V varies jointly with h and r squared, which I'm going to again write as the square of r. Okay? Okay. Yeah. There you go. And again, with joint variation, if r goes up and h goes down, you just have to analyze which one's going up by more, okay? So this is actually really, here, listen to this. This is going to be fantastic. You're going to like this, okay? This is for fun. Are you ready? Suppose r is doubled and h is cut in third, or cut by a third. I don't know, divided by 3. Okay, suppose h is just divided by 3. Okay, so what effect would that have on our volume, right? Would our volume go up or would our volume go down, right? Well, you'd say, well, getting doubled is smaller, or well, doubled is like times 2, right? And division by 3, well, it looks like I'm dividing by more than I'm timesing by, multiplying by. Except if volume equals pi r squared h, if r is doubled, then that's 2r squared. And then if h is cut by a 3, then that's h over 3. And so if I do that, then it's pi times 4r squared h over 3, which if you put all your constants out of the side, volume equals 4/3 pi r squared h. This 4/3 is increasing your volume, right? Because you're multiplying it by a number more than 1 now. If you compare that to 1 times pi r squared h, which is the original volume, right? So it's had a net increase, right? Yes, one went up and the other went down, but when you increase r, if by doubling it, that has more of an impact than dividing the height by 3. And so it kind of, that one takes over. And yeah, I hope I've explained that well enough. But if not, just ask me or leave a comment or something. I don't know. I can start responding to comments or something. That might be fun if you want to leave that there. Okay, now let's say I solve this same equation for h. So let's say h is, if I divide by pi r squared, I get v over pi r squared. Okay. Now, by the way, this is, if you want to rewrite this, this is like 1 over pi times v over r squared. Notice I haven't written any relationship with pi in either of these examples because pi is a constant, right? Pi doesn't change. Pi is not a variable. So I'm leaving it off to the side. It's not varying, yeah? Now, 2 things are happening here. Volume is sort of in the numerator. It's getting multiplied, whereas it's getting divided by r squared, yeah? Now, 1 over pi, that's your k. K is 1 over pi. So I'm just making a mental note of that because k isn't necessarily pi now. It's 1 over pi, okay? Because that's what you're multiplying by. That's the constant. Anyway, if you want to write a verbal description of this, we would say that h varies. Well, v, volume, is in the numerator, so I'll say it varies directly with the volume, v, and inversely, because it's in the denominator, inversely with the square of r. And done. There you go. And again, this does make sense. Suppose, just if you want to really make sure you've got this relationship correct, just kind of think about what would happen if one variable increases, right? So suppose volume increases and radius, r, I'm going to say r doesn't change, right? Well, if you increase the total volume of this cylinder, then the height has to go up, right? Because you kept the radius constant. All right, if I had a container like mother, go away, Mom. I thought I was on Do Not Disturb. What is it? What is this doing? Okay. Anyway, if volume goes up and r doesn't change, then the height increases. Yeah, because it looks like the same. So yeah, you have to. Now, if the radius goes up and the volume doesn't change, well, then the height has to go down, right? If I start with this object and then I increase the radius, then the height has to go down to contain the same amount of volume. So that relationship with the radius is inverse. It's inversely proportional. Okay. I think that's it. That's about everything I covered in class. That was the lesson for class, with some examples and verbal descriptions. And yeah, we did hand out a class worksheet that we're working on. I think it's uploaded in Schoology, but if you need another copy, just let me know and I'll get you that and you can get started on that. So hope this was helpful. Hope you enjoyed listening to this. Sorry for the interruption from Mother Dearest, but it only rang for a second, so we're okay. All right. Have a good night and I'll see you guys later.